A raw grain becomes transparency. A deposit becomes architecture. A mineral becomes a screen. And that transformation can make the material origin disappear. You don't look through a window and think about a mine. You don't hold a phone and think about silica purity. You don't look at a solar panel and think about sand. But the sand is there. And this is where the story becomes especially modern. Solar panels need glass. Screens need glass. As do buildings and bottles. The energy transition doesn't remove material demand, it just changes which materials we demand. And that's not necessarily a problem with solar power, but it means clean technology still has a supply chain. And if we're going to talk honestly about the material future, we have to be able to say two things at once. Renewable energy is necessary, and renewable energy still depends on mined, processed, transported materials. The question is whether we manage those supply chains well, or whether we let the clean final product hide the messy extraction behind it. But glass-grade silica is only one part of the story. The larger sand crisis is much bigger. As I said before, we're using around 40 to 50 billion tons of sand resources every year. That isn't just glass, it's concrete, roads, asphalt, land reclamation, coastal defense, buildings, infrastructure, ports, artificial islands, urban expansion, and the scale matters. At small scale, taking sand can look meaningless. Taking sand can look harmless. A pile from here, a barge from there, a dredger offshore, a pit inland, a beach replenishment project, a new city district. But at global scale, those removals add up. Changed rivers, eroded coasts, damaged seabeds, lost habitats, communities living with the consequences. That's why UNEP argues that sand has to be recognized as a strategic resource, not treated as an invisible background material.